Hey, welcome to Zona Mechanica. There is an MCQ on bending stress. Figure at the margin indicates the weightage of the question, that is 2 marks. A simply supported beam of span 6 meter and 75 mm diameter carries a uniformly distributed load of 1.5 kilonewton. What is the maximum value of bending stress? That is sigma B. What is the maximum value of bending stress? There are four options. Actually, this is a common data type of question and linked answer type of question. The first question was regarding the maximum bending moment, and this is regarding the maximum bending stress. And the answer of the first question will be used in the second question, and the answer of the first one is required in the solution of this second question. So the answer we got, maximum bending moment, was 6.75 kilonewton meter. The options are given in MPa, that is Newton per square millimeter. So I am taking this bending moment in Newton millimeters. So 6750, this is in Newton, and if I multiply with 10 to the power 3, then it will be in millimeters, that is Newton millimeters. Okay, now this question we can solve with the help of well-known bending formula, that is sigma B by Y is equal to M by I, where all the symbols are bearing usual meanings. So which implies sigma B is equal to M by I into Y. Clearly from the figure, this is a circular shaft of diameter 75 mm. Clearly Y is equal to D by 2. So I'm writing here M by I. I is pi by 64 into D to the power 4, and Y is equal to D by 2. Therefore, so which is equal to 32 into M by pi into D to the power 3. Okay, so now putting the values of M and D, 32 into M is 6750 into 10 to the power 3 by pi into D is equal to 75 mm cube. So it will come in Newton per square millimeters. So this will give something like 162.9746 MPa. So almost equal to 162.98 MPa. Clearly it's matching with option A. So option A is the correct answer.